Hello and welcome back to the Chintan Chats. And today we're quite lucky because we have a climate scientist with us, Abinash Mohanty. And Abinash is a climate scientist who is affiliated with the Intergovernmental Panel on Climate Change, IPCC. But the other thing that he really does is that he globally leads the research advisory IPE on all its climate change and its environmental sustainability work. And what that means for us here is he's got access both to what the scientists, the top scientists of the world are thinking, but he's also got a lot of experience on the grassroots. And Abinash actually spends a lot of time converting his knowledge into more democratizing his knowledge, rather, into things that the layperson can understand. And he's making climate change accessible from a science point of view. And that's quite unusual. So we are quite lucky. And thank you, Abinash, for being here.
Thank you, Bharati.
So, Abinash, I I was chatting with you just briefly, and one of the things I've slightly picked up about you is that you, as a young person, had an absolutely horrifying experience in 1999 around the super cyclone in Orissa. And that's what threw you into the world of science. So, would you like to shed a little light on this?
Yeah, cyclones to Odisha is no way kind of a distant story. Every year, at least one or the other kind of cyclonic storms were there. But in the history, in the modern history of India, 1999 super cyclone was one of those cyclones that had hit the hard. And it kind of hit so hard that 10,000 people lost their lives. More than thousands of crores of money was lost in terms of loss and damages, lives, livelihood, everything was impacted. And as a kid to adult kind of person who was just understanding how this can be horrifying, especially when I was placed in Bhubaneswar, which was the capital city. It was completely crippled. We never had electricity for almost 1 month and so, where the electricity was cut off. And then I remember the day electricity came back, it was the most joyous thing we had because fans, TV, other kind of comforts. And that's where it struck me kind of how these natural phenomenons are kind of becoming recurrent to devastating, right? And then the stories of floods, the stories of drought, epidemic. During those days, the stories of epidemic was also very high, and that's how the climate story was never looked at. It was more looked from a disaster perspective. But as I grew and started working, this is something that was there. Thought of how does the science play around, because climate change was evolving as a domain or as a line of study, and how is it going to impact people and lives, livelihood largely. That's what we call it as attributional science, and that's where I thought I'll start investing my time. I started working on water related issues, but from water to climate, because I was looking at how rains are going to make our rivers, or incessant erratic rains are going to make our rivers much more drier, how much we are exploiting. So it's an environment, climate, disaster nexus that triggered me to investigate more and more into this subject.
So, actually, that would be one of the only positive stories that comes out of that super cyclone, which hit our headlines for several days, because actually it gave us a climate scientist, basically.
Beyond that, there are many positive stories about how 1999 super cyclone set India's disaster risk management narrative. Odisha as a state, I mean, I just said 10,000 people lost their lives. But Odisha as a state, in 1999, when 10,000 lives were lost, one level down intensity cyclone Fani had hit in 2019. And when it hurt, the again, it was very horrifying cyclone. only 4 to 5 people. Again, 4 to 5 people is, again, the lives are important, but 4 to 5 people lost their lives. The number of casualties have come down. So that shows the trajectory a state like Odisha has taken in terms of improvising its disaster management, ensuring that lives are not lost, livelihoods still are lost, economies still are been shattered, and more importantly, infrastructures are also lost. So that is the breeze that needs to be covered with all of these. But one of the basic powerful stories, and it is globally now applauded in terms of how Odisha has been doing it, is its disaster management, and that's what is a template case. How you improvise, and then in 1999, Odisha was also not a very far off state. But in 2019, it had its science, it had its mechanism, it had its modus operandi in place to ensure that disaster management is more people centric. And so you need to have data and information more people centric way.
That's fabulous. So tell me, do you believe that disaster resilient infrastructure is actually is disaster resilient? Because we know from images how everything falls to pieces, because we can never predict how furiously waters hit infra, or how strong the storms are, and so on.
Uh, well, India's way of living, India's way of creating its infrastructure has always been disaster resilient. We never needed ACs. The Nalanda University had one of the great kind of cooling, aerodynamically structured infrastructure. So our way of life was in that way. But what had happened is our influence of not understanding the topography and then trying to overexploit. It is, I'll go back to that example. If your hand can carry a 20 kilogram of dumbbell, please do not overload it with a 50 kilogram. First, prepare your hand, become more muscular, then prepare it. So what we have been trying to do is, in a 20 kilogram appetite hand, we have been trying to put in 50. And that's where, when these events, all of these events are not related to climate change. What climate change has done is the cyclonic weather mechanisms or phenomena have been triggered in from events to turning into disaster. And that's what climate change has done. And we are responsible largely. When I say we, all of us human beings largely, that's a separate story of negotiation, which country is more kind of to be blamed, what countries are to be done. But what is happening is global south is facing the burn, and countries like India, states like Indian states are facing the maximum burnt of it. So all of our resilience discussions have to be centered around what is the carrying capacity, the house that we are living in, what is the risk landscape overall, and how is it. If you're driving in a car, then you need to have 4 airbags, that is more secure. Similarly, vis-a-vis to 2, right? What is the make of that car? Similarly, whatever we are doing needs to have that nexus of environmental footprint as well as the resilience footprint of some of these evolving risk landscapes. And in order to understand that, it starts with data and information, not with misinformation or disinformation. So you have to be very clear on how this information that is being channelized or that's been put in, how they are of larger aspect to all of us.
Absolutely. So, talking of data, some of your work, some of your recent work actually, has been profoundly, should I say, scary, for the lack of another word. For example, one of the statistics that your research has put out is that 85% of districts in India, 85, will experience some kind of extreme heat event or the other. What is happening here?
Okay, I'll take one step. I'll take a precursor to answer this question. When I devised India's first climate vulnerability index at a district level, that combined cyclone, flood, drought, all of those. And then we started breaking down floods into 3 parts: riverine flooding, coastal flooding, urban flooding, all of those. We tried kind of breaking it down. Similarly, droughts, when you say it is agricultural drought, that means you'll have water for everything but not for agricultural activities. You will have water for water to drink, but there will be no water for agricultural activity. That's agricultural drought, hydrological drought, meteorological drought. You'll have water, no water available in the water tables. What happened in Chennai, what happened in South Africa, all of those dry days are actually resultant of, and also recently in Bangalore, what happened about the water issue. So those are hydrological droughts. And then there is meteorological, when you don't have enough rain coming in, and that's how your wetlands, your water bodies are not been recharged. So we did that assessment to understand how is the hypergranular risk assessment, because talking of India as a country and its risk is different to that of a district in India, to that of a block, to that of a village, or to that of a city. And how do you translate some of these actions? And then at IP Global, we have been trying to establish with our partners climate risk observatories, and that climate risk observatory is the sole motto of that climate risk observatory is to democratize data, uh, make those data available to anyone and everyone in a more palatable format. And that's where this number has come down from our research, which is peer reviewed by World Meteorological Organizations, IPCC scientists, so on, others. This 84 or 85% of the Indian districts, it's a scary number. But
Yeah, it's really scary. And would you also tell us about which districts are not? If what are these 15% that have been spared?
yeah, so the 15% so far as spared is between the northeastern region, but the trends are looking very bad. In next 5 to 7 years, you will also see heat wave kind of conditions. Now there are thresholds different for different part. 40-degree in the northern India is a threshold, but the threshold for northeastern states is 30-degree, right? Anything above 30-degree is a heat stress kind of condition. So we divided a whole of India into different climate zones, and then start putting the thresholds to map it. So northeast is largely not getting impacted. Some of the union territories like Lakshadweep, Daman and Diu, others, Pondicherry, are some of those places which are not getting impacted by heat wave currently, but the trends are looking scary. But the problem with this heat thing is, heat is like I would say it's a slow poison kind of thing.
So what is causing this heat?
So heat. Okay, let me put it into this way. In this studio room, it is hot outside. If we start having two heaters here, then obviously there will be a situation where we all will be sweating, right? And the moment it gets out of our hands, I'll have to first take off my Nehru jacket probably, right? And then we'll try to find ways how our thermal comfort level can be minimized or subsidized. And that's where the whole ecosystem thing comes in. So a lot of heat from carbon emissions that we have been doing is been plugged in into the atmosphere. Now there is a cycle. Normally lands are hotter and oceans are also colder. So from high potential to low potential, always the heat flows. Now, whereas now our oceans are also getting warmer. So imagine that if this heat, if you open all the doors within the studio, then the heat will be just passing out. You'll still have thermal comfort. But if all over the studio is all closed and you have got heaters all around, it becomes a urban heat island kind of effect. It becomes a gas chamber, and that's where the heat is getting trapped. As a result, what is happening, your cyclic kind of processes in the oceans, depressions converting into deep depression. They, by the way, they are cyclic processes. They are not hazards, which are they're cyclic process. That is why you have got southwest monsoon, you have got northeast monsoon. All of your monsoon cycle are triggered from the oceans. Now, because they have been kind of also getting warmer, all of these processes are getting faster and faster. Hence, depressions are turning into deep depressions, into cyclonic storms, into severe cyclonic storms, and hence all of these weather phenomenons or the cyclic seasonal phenomenons are getting kind of transferred. So
Because of this heat.
because of this heat, because heat is, as I said, heat is very pivotal, intrinsic to all of the other hazards. Now, this heat has got direct impact on lives, in human health, in terms of livelihood, and there are chain of string of event that comes into it.
Absolutely.
So that's how all of these are kind of clubbed together to see how your so a lot of in the climate domain, a lot of people say mitigation and adaptation. It is actually a combined process. If you there cannot be any mitigation without adaptation. There can't be no adaptation without mitigation of climate. So climate action, and that's how you have to put it, or else we will be chasing the wrong horse at the wrong time, and then end up managing one event which is turning in no time into a disaster.
That's really interesting. But what does heat mean for jobs?
Ah, um, Indian International Labour Organization had did a study couple of years back, and India is going to lose 30 million jobs by 2030. That's a huge number.
20 million.
20 million jobs by 2030.
How do these jobs go
Yeah,
away?
so these are largely coming from the manufacturing sector, the sectors which are going to be impacted largely: manufacturing, construction, so on and so forth.
How
So what
manufacturing?
Yeah. So what happens if the temperature outside is increasing? Then what happens is your productivity level comes down substantially. If you don't have access to cooling appliances, then your productivity comes down. You need to be hydrated. That is why the first advisory in a heat related heat stress you'll see is ORS PGA. You need to drink ORS. You need to be hydrated. That's the first thing. So your thermal comfort level is directly related to your productivity. The 8 hours of productivity will come down to 5.5 or around 5 hours of productivity. As a result, what happens? Your productivity is directly related to the productivity of that unit or that manufacturing unit, that construction unit, and hence, as a result, that delay that it gets cascaded into the larger revenue share.
I'll just ask you something more. So you're saying that manufacturing will be hit, and that's because the workers will be hit. What about manufacturing itself? Doesn't some of that get severely impacted in the heat?
It's a whole supply chain. So if you consider anything in silo, then that's a separate narrative. But if you consider the whole supply chain, then yes, heat's got an impact. Because what would happen is, if a product which has been produced in a factory needs to be reaching to from point A to point B, and that will be impacted because you have got high heat stress condition, your temperatures are increasing, you need to have cooling. Hence, your the product shelf life is going to come down. So all of these are a kind of supply chain.
What happens to our food? What about food security?
There's going to be a dent because of climate change, and all of us, this is like a no-brainer. Climate change is going to impact our food security largely, but what is going to happen more and more is we are going to get adapted to food that we were never used to eating. Every ecosystem has its own food way of life. That food way of life is different what we eat in southern part of India to that of eastern part to that of northern part, right? And that is going to be impacted. So what is going to happen is the rice producing, if I have to put it in very simple terms, the rice producing states are not going to have enough water to produce rice. They will have to shift their agriculture from one crop to the other. And as a result, once you don't have the inflation, food inflation is going to increase. And if food inflation is going to increase your purchasing power parity, if it is not commensurate, then that's going to impact largely how much you are going to buy in order to have your sustenance, right? So it is a question of how much I want, what am I getting, and at what cost am I getting it, and at what place. That's how. So, and that's the supply chain that it looks, the heat is going to impact largely. So if you look at it from a climate science perspective, it triggers disasters like floods, cyclones, so on and so forth. But if you look at it from a socio-economic perspective, it is going to dent our livelihoods, largely our food security, what we are going to have on our food plate, what breakfast are we going to have. The for Gen Zs and for all of us who are largely dependent on coffees, our coffees are going to be dearer because of climate change. Similarly, for those who have drink a lot of alcohol, beers are going to be costlier.
Tell us why. Why is beer and coffee going to be more expensive?
So there is a temperature threshold for everything,
Yeah.
right? All of us have got a temperature threshold. And Western inhabitant will not like Indian weather conditions so much, and we will also not like the Western conditions so much. So there is a body what we call it as thresholds or thermal comfort levels that we have. And similarly, our plants, our agricultural saplings also have their thresholds. Now, if that is going to be changed, you're not going to, suppose if you drink 8 liters, you are only given 5 liters, there is going to be, your body is attuned to 8 liters. You can't change it substantially. You have to change it gradually. It can't be an erratic abruption. And climate change is just making it erratic, abruptive. And that disruption which is happening within the processes is going to create that productivity loss. And hence, your dependency is not going to come down, but your product, it's a demand and supply. So we started from climate science, but we are ending into the microeconomics of demand and supply, the Kuznetsov's discussion.
Yeah, but that's what it is, the world turning upside down. And talking of the world turning upside down, since President Trump has taken over, he has, really been cutting down several arms of government. And in that, one of the things he's done is he's cut down the work of NOAA, which is the National Oceanic and Atmospheric Administration. And I've been reading, including in the Hindustan Times, that it seems that some of the work that this agency did on climate science, modeling and global data sets was actually quite important for India, because India depended on it for monsoonic forecasting. And it's quite a disaster now to be deprived of an important data set. So what do you think? What is going to happen now? Even if we have other data sets, how does this one action of Trump impact forecasting for millions and millions of people in India?
There is going to be a disruption, but I'm not worried much as a climate scientist because our dependency on some of these Western agencies have been quite a lot. And what this step, and there are already steps, India has been having some of the best cyclone forecasting systems. Early warning systems has been very good, and the call from United Nations on early warning for all is kind of, India is leapfrogging it, fast forwarding that slogan or that tagline. So that gives us an opportunity, a lot of endeavors to speak of. All of these data sets are global data sets. They don't mean anything to all of us until unless they are churned in our way of life. 40-degree or 45-degree outside means different to you, Bharati, vis-a-vis to me, vis-a-vis to the rickshaw puller, vis-a-vis to our house helps, vis-a-vis to anyone and everyone, right? So that data needs to be downscaled. That's where the ensembling and tools like ours, Climate Risk Observatory, some of the other endeavors by India Meteorological Department, South Asian level, World Meteorological Organization, they have been trying very hard to do it. Yes, there will be a dent, but that dent can be fixed in terms
So
of
sometime we'll have to live with that dent for a year or so. Because we should.
I don't think because there is already a process which has already commensurate at a
What
regional level.
dent you're talking about?
So dent is the cross exchange of knowledge, right? People who have been churning numbers from 15 or say 5 decades, we will have to start churning and exchanging those numbers. Validation is more.
So we need to find new allies, basically.
Yes.
New data allies.
New data allies. What happens with climate modeling is there are level of uncertainties, and those level of uncertainties can only come down once you start exchanging your data, validating it, revalidating it, revalidating it, and revalidating it. So that's what is the process, and that revalidation is going to, which was happening at a faster rate, is going to stop to a larger extent. But this also opens an homegrown, if you talk about the climate deep tech space, that's where our homegrown technologies, homegrown climate scientists, data scientists are coming forward in terms of solving this issue, not just at an India level. And that also gives us an opportunity as a global south country to leapfrog in terms of exchanging some of these ideas between the global south country.
And
so no one country,
as well as lead, I would say.
exactly.
Yeah.
And to be very honest, no one country should dictate what people all around the world are going to live and how they want to live. It should not be dictated by one, and that's never a healthy thing. So we should better find our own ways and fight it out with strong force in terms of making science become more and more people centric, because that's where the real bug starts and the real bug stops as well. Until unless you empower people with data and information, people are not going to become resilient, whether it is climate change or whether it is geopolitics or whether it is education, any of the developmental agendas you speak of. Data is the foremost, but what data and what information needs to be understood, more importantly needs to be validated, and that's where is the starting point.
So, really, it's an opportunity that we didn't want, but which has presented itself to us. So now we actually have to find new data allies, but we also have to kind of ratchet up our own internal talent and skill. And that's going to be my final question to you: is what is the emerging, even before Noah was impeded, what is emerging in the space of climate tech and tech in India in the context of the work that you do?
Uh, a lot of work is emerging. Climate deep tech or AI for climate is some of the emerging fields.
What is, explain what
I'm
happens
just
with AI.
yeah. So AI for data is some of the food supply startups, or they're no more startups actually. They are bigger than that, I would say. On the click of button when we start ordering our food, through some of the mobile applications, they have started integrating climate science and information, so that the rider who comes down taking your food, whether it is he's going to be drowned by a unseasonal rain, or they are going to take longer time because there is a heat stress outside. All of those informations have been clubbed into our way of life, and that's where the integration of deep take climate data is coming into picture. Second is in the physical risk from the banking and financial institutions. Now there is a growing demand. RBI has also sent out guidelines now to the banks to start with, how much of the banking portfolio is actually going to be linked, or how much is climate resilient, climate sensitive. If you are lending 100 rupees, then out of those 100 rupees, how much can withstand this climate shocks, how much is going to break down. So all of those data driven risk informed decisions are going to be led by the deep tech AI, and these modeling and simulations provide you with scenarios. If I have to summarize it, then if you have got a blood pressure as well as diabetes, and top of it COVID, then you're more likely to be ending in an ICU, but you will get yourself known because of this deep tech information. So you start preparing it way in advance. So what happens, your time of response, whether it is a disaster, whether it is a personal impact on your health or on other way of living, those response time are going to be faster. Similarly, what kind of AC you are going to put in your house, whether it's energy efficient AC or an energy efficient fan, then similarly, if you have to make people live in colder conditions, then you need to first start with energy efficient fans, and those energy efficient fans need to be produced. But what is the market? Your market is this 85% of heat stress hotspot where people need fans, right? You cannot shy away. So and that's the narrative, whether you look at it as a problem in hand or a problem that needs a solution in hand, and you start building onto it. And as a young country, I think we have got enough talent. Our startup ecosystem is so large. Couple of days from now, Startup Mahakumbh is going to start up, where it's a conglomerate of how all of these ideas are coming together to solve some of the rarest to some of the common problems that we have been facing. And that's where the innovation lies.
Fabulous. So, thank you so much, Abinash. It was fascinating talking to you, and there's so much silver lining to what appears to be a very hot and scary cloud, hot and humid cloud. Thank you so much for your knowledge and for sharing it today.
Absolute pleasure, Bharati.
Thank you.